Hello students! So this is the third and final video that will come out of this packet. So what my goal in this video is to talk about graphs of functions like this. And so this will feel very much like a blast from the past. What happens when you multiply a function by a constant? What happens when you multiply the input of a function by a constant? But we'll focus on that in particular to the trig functions sine and cosine. So let's start with this. So here are the graphs of sine and cosine. And let's just take advantage of let's do a quick matching problem. So there's the graph of a function. I'm just tracing it because it's a little bit faint on my screen. I don't know if it's faint on yours. Here's the graph of another function. And I'll tell you for a fact that one of these two is sine and the other one is cosine. And let's try to think about which one is which. So let's look at the red function. Is the red function an even function or an odd function? It's odd. Well, remember, cosine is even, sine is odd, so this red function must be sine of x. Additionally, apparently this function passes through the point 0, 0. Is the sine of 0 0? Yeah, but the cosine of 0 is 1, so the red one is sine, can't be cosine. There are a half dozen other ways you could check. You could check by seeing its value at pi over 2. So I guess that means the blue one must be cosine of x. So let's think about this. How can we get the graph of 2 times the cosine of x times 3? So let's just think about what these things do to graphs. So what happens when you multiply the variable x in a function by a constant? Well, that will compress the graph horizontally by a factor of 3. So that will compress the graph of cosine of x horizontally by a factor of 3. Said a different way, all x values get divided by 3. So, good enough, that's not news. What happens when you multiply a function by a constant? So what will this 2 do? Well, it should stretch everything vertically by a factor of 2. So this 2 will stretch vertically, and you're not here to tell me how I've misspelled stretch, but I think that's right, vertically by a factor of 2. All y values will be multiplied by 2. So let's just go through and do that. So the graph of cosine of x, because I want 2 times cosine of x times 3, it passes through the point 0, 1. Right? Cosine of 0 is 1. So I should take the point 0, 1. I will compress horizontally, so I'll divide that 0 by 3. I will still be at 0. I'll stretch vertically by a factor of 2. So I'll multiply 1 by 2, giving me 2. So I'll be at the point 0, 2. And I'm going to go ahead and point out that I haven't given any sense of hash marks. There's no scale in this resulting graph. So I won't be careful about making sure all of the scale is consistent because, well, you've seen that I'm incapable of doing that even when I'm writing pencil and paper, writing pad as sidebar pen on tablet is even worse. So let's trace this next point. So this next point, where cosine is 0, well, right, it's halfway between 0 and pi, so that'll be pi over 2, 0, and yeah, cosine of pi over 2 is 0, right? Cosine of a right angle is 0. So that point, the x value will get divided by 3. So pi over 2 over 3 is pi over 6. 0 will get multiplied by 2. 0 times 2 is still 0. So it will pass through the point, and like I said, I'm not going to worry about having a totally good scale. It'll pass through the point pi over 6, comma, 0. Then you'll see this point here at pi negative 1. X value will get divided by 3, y value will be multiplied by 2. You'll end up at x value gets divided by 3, so pi over 3. Y value gets multiplied by 2. Y value is now negative 1. And let's just go ahead and in between it should look similar to the graph of cosine. Next I see this point right here at 3 pi over 2 comma 0. Do the same thing. I'll divide that x value by 3. 3 pi over 2 over 3. So chances are you can do that in your head, but I'll do that off to the side. 3 pi over 2 over 3. So you multiply by 3, and then you divide by 3. Neat. So the next point we'll go through is pi over 2, comma, this 0 will get multiplied by 2, but 0 times 2 is still 0. So pi over 2, comma, 0. And all the way up here at the end of one full period is 2 pi, comma, 0. Do the exact same thing. X value gets, 2 pi, comma, 1. 2 pi will get divided by 3, resulting in 2 pi over 3. That y value will get multiplied by 2. So you'll end up way up here at 2 pi over 3, comma, 1. And now you'll notice that we've just gone through one full, I'll say period, even though the definition will be at the bottom, one full period of the graph of cosine. The graph of cosine now just repeats. So the graph of cosine, the graph of 2 times the cosine of x times 3 will also repeat. So I'll just take that exact graph and I'll copy it. And maybe I'll give this value right here. So that will be 4 pi divided by 3. And let's do one more period. Nope, that 1 should be a 2, shouldn't it? Next you'll have 6 pi over 3, comma 2. So 6 pi over 3, well that's just 2 pi, comma 2. Neat. And so now you can really see that the scale is not the same above and below. But that's okay. We can get the graph for negative x values by the same thing. The graph will just repeat. So this will be negative 2 pi, comma 2. Here I see negative 4 pi. Nope, negative 2 pi over 3, comma 2. Negative 4 pi over 3, comma 2. Cool. We could do something similar to get the graph of 3 times the cosine of x times 2. And, in fact, I think I don't want to spend video time on it. Instead, you do it. I'm going to pause this, and I'll come back with the graph. All right, we're back. So here's the graph. So what has happened? The original graph, let's see, the original graph would have had, and I'll go ahead and highlight one full period. This point would have been 0, comma 1, but the x value gets divided by 2. The y value gets multiplied by 3. This point would have been at pi, comma negative 1, right? Cosine of pi is negative 1. The x value gets divided by 2, becoming pi over 2. Y value gets multiplied by 3. Negative 1 will become negative 3. And then the graph will just repeat from there on. Similarly, you want the graph of cosine of 2x. again, we'll see it by, I'll do it, we'll come back. And again, there we see it. It should look the exact same as the graph of cosine, except that all of the x values have been divided by 2. So let's take a look at that. So let's ask about the period of this function. So what does the period mean? The period is how long the function takes to repeat. So if I follow that far along the graph of cosine, you'll see that after that after the graph just repeats that same red pattern forevermore. So the period of the graph of the period of the graph of the cosine of 2x is equal to period is pi. In general, you can compute the period of any thing that looks like sine or cosine of a multiple of x as follows. I apologize for those voop noises. I will get this shut off. So if you want the graph, if you want to think about the period of the anything that looks like cosine of omega times x, let's start by just thinking about the graph of cosine of x. So here it is up here. Cosine of x is this blue function. So you get all the way up to 2 pi, and then it starts repeating. So the graph, so cosine of x when you multiply a graph by a constant, omega, what does that do? Well, right, that will compress horizontally by a factor of omega, whatever that number omega is. So think about what that would do. That would take something that originally had a period of 2 pi. All of the x values get divided by w. So instead of repeating every length of 2 pi, it will repeat every length of 2 pi divided by omega. So the period of these functions are 2 pi over omega. And it's important that omega is a constant. You couldn't use this to compute like the period of the cosine of x squared. In fact, that's a non-periodic function. If you look at the graph, you'll see that it doesn't have an even a period over which it repeats. So let's do this in practice. So let's sketch the graph of the sine of pi times x. Well, first let's try to compute the period using this formula, and then we'll see if it's reasonable. So the period of the sine of pi times x, well, that should be 2 pi, but then that should be divided by pi. Right, because there's the thing that's called omega in the theorem above. So the period of the sine of pi times x is 2 pi over pi. That's just 2. So sine of pi times x should repeat every 2. And let's see if it actually does. So let's look up at the graph of sine of x. It's the red one up there. So let's chase through some points. So this point, 0, 1, that x value will get divided by pi. So the x value is 0 divided by pi, still 0. This point right here will be pi over 2, 1. The y value will stay the same. The x value will get divided by pi. Well, pi over 2 divided by pi is just 1 over 2. The next point that the graph of sine goes through is pi, 0. Well, pi divided by pi is 1. Then the next point, well, if I were to look using this, that you see is 3 pi over 2, negative 1. Well, 3 pi over 2 divided by pi is just 3 over 2. And then finally 2, 0. So the graph does something like that. And you'll notice that in the graph of sine, we've just gone through one full period. So the graph of sine is just going to repeat. So this graph will repeat. Yeah, so we see that this sure looks like it's repeating every interval of length 2. So there's one comment. I haven't addressed at all this word amplitude, but the homework does address the word amplitude. This is one of these moments where I am requiring you to read the book to grab some of the content that will appear on the homework. Wonderful. Well, I hope you enjoyed this series of lectures. I'll talk to you in the next one.